Greetings, my name is Daniel Sánchez from Osaka University, and this is a summary of our recent work titled Dual Arm Manipulation Planning for Tethered Tools. Tethered tool manipulation planning can be considered to be a complex task. It can be said that it involves both the manipulation of a rigid object, which is the tool, and the indirect manipulation of the tool cable. The tool cable may cause problems in the robot workspace. It can collide with some objects in the robot workspace, as you see in the left example, or it can get entangled around the robot arms, as you can see on the picture of the right. To solve this problem, we have implemented and proposed two different solutions. The first is a cable shape simplification with constraint motion planning approach, and the second is a cable maneuvering approach. For both methods, we make use of a tool balancer. A tool balancer is a special mechanism that acts as a cable source. This cable has a constant tension that strengthens the cable shape, and it makes it form a straight line between the tool and the tool balancer. We also make use of a second mechanism, the cable slider, which is shown in pictures C and D. This is used for our second method in order to make the robot control the shape of the cable. For the first method, we implemented a constraint motion planning approach. Basically, we use the straight shape of the cable to our advantage, and we were able to draw a prohibited region in space according to the current position of the robot, the position of the tool balancer, and the in-hand position of the tool. With that, we constrained the planner to prevent the cable from entering the prohibited region. We implemented our planner and compared it to a normal manipulation planner. And as you can see in the positive example, which is our proposed planner, the robot is able to avoid the winding of the cable. It also avoids getting entangled with the cable, as you can see in the negative example 1. It also prevents the excessive bending of the cable. In the positive example, you can also see that the robot is able to complete its whole manipulation task and place the tool in a desired position without any inconvenience. For our second method, we implemented a cable maneuvering solution. In this case, we use the straight shape of the cable to our advantage, and we implement a second mechanism called a cable slider. This is a cube-shaped tool that has a through hole from which the cable can pass. The robot uses this cable slider in order to pull from the cable and modify its shape. Here are some implementations of our planner in real-world environments. As you can see, the robot is able to grasp the blue cable slider and modify the trajectory of the cable at all times, basically avoiding entanglements and collisions with the cable. We were also able to implement our solution without making use of the tool balancer. In this case, the robot uses the cable slider to modify the shape of the cable and avoid obstacles in the robot workspace, which it can do, and it can use that to finish the task without moving the objects in the workspace. And finally, this is a final implementation in which we challenge the robot with a cluttered environment. In this case, there are many obstacles that the robot must avoid. The robot was able to successfully use the cable slider to maneuver the cable around the workspace and prevent the cable from colliding with any of the obstacles, finally getting its task done. That was my whole presentation, and I thank you for your time.